Welcome to this module of Professor Messer's free CompTIA A+ certification training course on working with disk partitions and file systems. I'm your host, James Messer, and in this module, we're going to go through what we need to know about working with disk partitioning, with file systems, and learning more about how to create, view, and manage disk directories and files and operating systems. You'll notice that the requirements from both the 220-601 and the 220-602 exam are almost identical in the words that they use to do this. This 220-602 exam expects you to go through a little more about why you would use this and how you would set up this partitioning process, where the 601 exam is really looking for more overall understanding of the partitioning. We're going to go through both of those in this module. We're going to look at disk partitioning, give you an overview of that piece, what different types of partitions there are. We're going to understand more about Windows-specific partitions and volumes. There's things in Windows that are a little bit different than other operating systems. And we'll look at how to partition both basic and dynamic disks. We'll end the conversation today by looking at file systems, give you an overview of file systems, and look at different types of file systems and why they are important. Let's start our conversation with partitioning disks and why it's useful to be able to do some disk partitioning. Whenever you start preparing a disk for the very first time, this is usually the first thing that you do. You buy a new hard drive, you install it in your machine, and before you can perform any type of function to that disk, you have to create a partition. You have to allocate a section of that disk that will be used by your operating system. Now, on most people's machines that they have at home, they may have everything in one big partition, but there may be instances on file servers, on other large devices, or even on the system you use at home, where you may want to have separate partitions set up on your system. If you're getting this hard drive from someone else or from a system that was running somewhere else, the partitions on there may not be compatible with your operating system. So that's yet another reason why you might want to have a partition up and running. Now, a hard disk generally can have up to 4 partitions. We'll talk about the different kinds of those in our system, but this 4 partition limit goes way back to how the partitioning process works and how it initially was implemented in a PC environment. Now, there's ways to have more than 4 logical partitions on a system, but 4 physical partitions is your maximum on most of the environments that you'll work with. Whenever you're working with a partitioning system, you're doing anything with disk partitioning, you want to be very careful. There is a lot of serious potential here for losing data. You can make one change to a disk and all of your data will disappear. So you're going to want to make sure that you have a backup of things if you're going to be making a very major change to the way the disk operates. And one thing to keep in mind, though, is you don't do disk partitioning every day. It's not something that's a very common occurrence. And yet another reason why you want to be very careful when performing it, because you may not be familiar with the environment. You're going in there every week, every month. You may want to make sure that what you're doing isn't going to cause a problem for you later. Remember, always have a backup. Why would we ever need to create a disk partition? Well, the first thing a partition is good for is separating the physical drive itself that you have into smaller logical pieces. It's very useful to keep data separated this way. In fact, you can have a separate operating system on every single partition. You may have a computer that boots up in Microsoft DOS, in Windows 3.1, in Windows 2000, in Windows NT, in Windows XP, and Windows Vista, all running on the same hard drive, all running in separate partitions. So it keeps things very clean. You can keep your data separated that way. You don't always need multiple partitions. It is possible to run multiple operating systems off of the same partition. It's a little more complicated when you do it that way because all of the data is integrated into itself. It's all there on the same drive, if you will, in the same partition. It requires a little bit extra management on your part, but it can be done. In most cases, for home environments, everybody usually just keeps everything in one big partition. They're not running multiple operating systems, and they just want to have one big drive available, Drive C. That's where everything is on Drive C. We'll talk more about how other manufacturers might set up these drives and set up these partitions in different ways. Now, if you're running different operating systems, you're running Windows and Linux, this is a great thing to do, is keep the partition there because it simplifies the process. It also allows you to have different file systems running on your system simultaneously. We'll talk a little bit later in this module about why different file systems might be useful to have available to you. You'll often hear partitions referred to as volumes. This is, in Microsoft terminology, a partition that has then been formatted with a file system. So it's almost like the volume name is something that's finally usable by the end user. The partition is created, you format it, it then now can be really called a volume. There are two different partition types that we will use in our Windows environment, in our PC environment. The first is called the primary partition. This is also referred to as a logical partition, but almost everybody refers to it as the primary partitions. These are bootable partitions. These are partitions you can set up and you can boot from them. These primary partitions often have different operating systems running on it. So you'd run Windows on one bootable partition on one primary partition. You would run Linux on another primary partition. You would run Windows Vista on another primary partition. But remember, you can only have a maximum of 4 of these per hard drive. Now that may seem like a lot, but when you start tinkering around with different things, you're getting A+ certified. You may want to run multiple operating systems on multiple partitions. This may be something normal for you to do. Only one of these primary partitions can be marked as active on a hard drive. The active partition is the one that's designed as being bootable by default. Doesn't mean you can't boot off of any of them, but one of the partitions has to be active, and you have to name which one of those it might be so that you do have a default partition that you will boot from should you not choose any other option. The other type of partition you'll find is something called an extended partition. Now, I mentioned you can only have 4 primary partitions per hard drive. Well, you can have 3 primary partitions and an extended partition. So that's one way that you can take this idea of 4 partitions per hard drive and add to it, because what you can do is inside an extended partition, I can create little logical partitions. This was really created as a workaround to this limit of 4. So by creating this extended partition, I can now have multiple partitions within there. Now, the problem with, or the limitation of an extended partition and having these logical drives within it is the logical drives inside of this extended partition are not bootable. But other than that, they work, act, and look like any other partition that you might have available. It's just that they happen to be existing inside one of these extended partitions. We'll look at this graphically so that you can get an idea of how that extended partition is created, and it will probably make a lot more sense to you once you see it that way. Here's how my system is set up, one that I did, where I have 3 of those basic partitions set up, 3 of those primary partitions, an E and an F and an I, and then this little green spot shows the extended partition around that, and inside the extended partition I have a G drive and an H drive and then some other free space. So I've got about 150 megabytes of free space within this extended partition, and then I've got 3 of these other primary partitions. Now I could have one primary and still have the extended piece there. I've just sort of loaded this up with the maximum to give you a feel for what you possibly could do on your system. Let's build some of this ourselves. I want to show you how all of this works. Here's our Windows desktop, and in this scenario, I've just added a new hard drive to my system. I've not done anything else with it. I'm still booting from the old hard drive, but I've added a new hard drive into this. Now, the way that you would see that is from our disk management. If you right mouse click and choose Manage, you will bring up your computer management console. And I'm going to maximize this because we're going to need all of this space on our screen available. And I'm going to choose the view here under Storage that allows me to do disk management. This is where you go whenever you want to start looking at partitions, whenever you want to start managing partitions or see how a system is configured, you go into this disk management section. And what it will do is show you all of the volumes that you've created. Again, a volume is a partition that has been formatted. So the only volume I happen to have in my system is the C drive. It's a partition. It's a basic system. We're going to talk more about that in a moment. It's formatted with the NTFS file system, and it's healthy. It's running just fine. It's a 4 gig drive. It shows me how much free space and other things that I've got configured on here. If you notice down further, these are the physical drives on my system. I have a disk 0 and a disk 1. My disk 1 is the new 200 meg drive that I added. And then I've also got a CD-ROM on here. Now you could see this entire 200 gig drive is currently unpartitioned. So I want to create some partitions there. The way that I do that is I can right mouse click and choose New Partition. and it brings up this new partition wizard. It says we're going to create a partition on something called a basic disk. And this basic disk is one that has primary partitions, extended partitions, logical drives. We can use any version of Windows or DOS. We can do anything we want with these. So very flexible. Let's click next. First thing I want to do is create a primary partition because I might want to boot from a partition on this drive. You can see it even tells you there's 3 types, a primary, an extended, and a logical. Notice that logical is grayed out. The only place that you would ever have a logical drive is inside an extended partition, and because I haven't created an extended partition, I therefore can't create a logical drive inside of it. So it's going to be gray here. Let's start with the primary partition. And let's say my primary partition, I would like to create and make it 50 megabytes in size. This is a 200 megabyte drive. I'm going to create one that's 50 megabytes and click enter. And you can even say, what drive letter would you like to assign to it? Well, this is nice. I can just make it drive E, which is the next one on my list, or I might want to make it drive J. You also might want to mount it in an empty NTFS folder, which means it doesn't show up as a drive. It shows up as a folder underneath your existing drive. That's an interesting thing to think about. You don't even see that there's an additional drive there. It just shows up as a folder that's on our existing hard drive. So it's a very easy way to add to existing drives in a way that your end users never see an extra drive in your system. They never see an E drive or a J drive or anything else. You could also say, just don't put a drive letter there right now. We may come back to that later. We'll add drives later on or drive letters to it later on, or we may want to do something else with that drive. In this case, I'm going to assign drive letter J. And we're going to say that we can format it with NTFS. We can format it with FAT or FAT32. Those are file system types. We're going to talk about those in just a moment. What I'm going to do is say, do not format this partition. And then it says, great, well, we've successfully completed the wizard. Here's what we're going to create. A primary partition in disk 1 of 50 megabytes of drive J. We're not going to put any file system on it currently. And we're going to use the default allocation unit size and click finish. And it will create graphically on the screen. It will show me that in disk 1, it has created a 50 megabyte hard drive partition. So now we've created a 50 megabyte partition on this hard drive. Notice we've got a primary partition, 50 megabyte. We've got 148 megabyte that's currently unallocated. So let's create some more. We can have up to 4 partitions. So I'm going to create very quickly another primary partition. We'll make it another 50 megabyte partition. Just with the next drive letter. We're not going to format it. And finish. Then I'll create another new partition, another primary partition. We'll make it 50 megabytes. Give it the next drive letter. We'll not format that one either. So we've created 3 partitions exactly the same, 50, 50, and 50. We got this extra 50 left over, but instead of having another primary, I'm going to create an extended partition. We're going to use the entire rest of the space as the extended partition. Notice it doesn't even ask you what file system you want to put on it, what drive letter, because an extended partition doesn't have one. We still have to create logical partitions within the extended partition. So I'm going to create a new logical drive. In fact, that's my only choice inside of this partition. And I'm going to make it just for purposes so that we can see what's going on. We'll make it 20 megabytes. I'm not going to format that one either. And we'll do one more just so you can see how all of this works. New logical drive. We'll make it another 20 megabyte logical drive with that drive letter and that partition. So just that quickly, we have created 5 different partitions with even some more extra space on this disk. Some of them are primary partitions that we could boot from. Some of them are extended logical drives that are within an extended partition. So it really depends on how you want to set up your machine, the types of partitions that you'll need, how many partitions you'll need. In most environments, you're not going to have a disk that's quite this busy, but the capabilities are there to do it. There's a number of reasons why you might want to have this here. One of them is to separate the data. and have these separate bootable partitions, but there may be requirements for different operating systems and different applications to be able to use these drives in different ways. When you get into very, very large drives, there's definitely a reason why you want to partition some of these things out and allocate them off onto different virtual devices or different applications. So keep that in mind as you go through understanding the creation of the partitioning process, why it's put up here this way, why it's created this way, and why there are so many different options and ways to go about doing that. One of the things that you saw in our partitioning process were these different Windows disks. There was a basic disk and there was a dynamic disk. Now, the basic disk storage is the one that we just created. We created some very basic disks that are available. These are the ones that were in the original DOS version. Those were referred to as, at that point, they were just normal partitions. Now we call them basic disks. They exist as primary and extended partitions. You can put logical drives inside of them. Now, the different partitions cannot share data between them. So they are really separate partitions that have no communication between the two. They really are created separately. Dynamic disks is something that was created in Windows 2000 and has been used in every Windows operating system since then. What you can do with dynamic disks are things like spanning or striping or mirroring, so that I can take and create larger volumes from multiple drives. I can split data across the physical disks, and I can even duplicate data across these dynamic disks so that there is a mirror of the data. And we'll talk more about that in just a moment. Not all Windows versions will support all of these capabilities. Windows XP Professional versus Windows 2003 Server, different capabilities. Some of these capabilities are there, but not all of them, depending on the operating system version you're using when you're taking advantage of dynamic disks. We'll talk more about the spanning and striping and mirroring in another video where we go into using your disks in ways to create redundancy and fault tolerance. But for now, just keep in mind that a dynamic disk is really used for more of those advanced capabilities, and the basic disk storage is the one that's used for everything else, the one you'd find most common in your Windows environments. When we were creating those partitions, one of the options at the end of the creation process was to format the partition, and then it asked us what file system we wanted to have on the partition. And you'll notice it gave us an option of FAT, FAT32, and NTFS. Those are file systems. Before you can write any data to a drive, it has to be formatted, and you have to format it with a specific kind of file system. This is really a way of creating a foundation or a master index that then will be used to store the data. So those three different file systems, the FAT, the FAT32, and the NTFS, were a little bit different, had different capabilities from one to the other. Now, this particular format that we have on the drive of this file system, FAT and FAT32, is very popular. It's been around for a long time, and it's one that's very well known. So different operating systems could even write to a FAT or FAT32. A Windows operating system and a Linux operating system could both write to a FAT32 drive. So if you wanted to have data available on this partition and you didn't care what operating system you happened to be booted in at the time, FAT32 is a pretty good choice to use. Now, NTFS is also a very popular file system. Many operating systems can read and write to NTFS. And so there's also multiple file system types that operating systems can write to. As we saw, Windows, for instance, Windows XP Professional can write to FAT, FAT32, and NTFS. So you're not locked into one particular type. The operating system you might be using might be able to do a large number of file system types and read and write to multiple different file system types. So it just depends on the operating system you're using as to the type of file format or file system that will be accessible to you. So which file system do you use? Well, there's some differences between FAT, FAT32, and NTFS. FAT stands for File Allocation Table. One of the very first PC-based file systems used this file system type to be able to store its files. So this goes back to the 1980s and its capability in being able to do that. Well, there were limitations with that, especially when larger drives were created. So a new file allocation table type called FAT32 was created, and this was natively supported in Windows 2000. And one of the things that it allowed was to have volume sizes up to 2 terabytes of size. At the time, that was amazing size. These days, it's very easy to find a volume size of 2 terabytes. The maximum file size on a FAT32 partition is 4 gigabytes. And you may have seen this, you may have run into this before, because 4 gigabytes of data, very easy to see with some very large disk images that we have these days, operating system images, movie types. If you're doing any type of video editing, you'll very easily reach 4 gigabytes. And you'll find that if you try to copy a file or store a file that's over 4 gigabytes onto a FAT32 volume, it won't let you. It'll say it ran out of disk space because it only allows file sizes of 4 gigabytes and smaller. So that's something to keep in mind. It's a very good reason to go to NTFS. NTFS is a file system that started with the Windows NT, and you can have it in files operating systems after that, that gave amazing amounts of improvements to the file system type. Not only can I have very large files, but I can have quotas and file compression. I can encrypt data on the drive as I'm writing it to and from. I can have symbolic links. There's security. We've already seen some of the recoverability type capabilities and redundancy built into this. To be able to do those things, I must be running NTFS if I want to have those capabilities integrated into the operating system. There's many different versions of NTFS. It's been improved on and added to through the years, but most Windows operating systems are able to read and write these NTFS systems in many different ways. You may also see a file system type called HPFS, High Performance File System. You don't really hear it referred to much anymore. It's a file system that was created when Microsoft and IBM got together and created an operating system called OS/2. Ultimately, Microsoft and IBM decided not to do additional work on that, and Microsoft created Windows NT as their next generation of operating system and created NTFS to go on top of that. So HPFS was where things started, and NTFS was really a generation of after those HPFS systems were created. Still, there's similarities between the two. HPFS was very comparable in what it was doing, but NTFS really took it to the next level. And so you can see now with all of these extensive improvements with the file compressions and encryptions and symbolic links that NTFS really is that next generation of data file system and really goes well beyond what HPFS could ever do. In review, we've looked at disk partitioning. We've created some partitions on our hard drives. We've looked at how Windows uses partitions and the different ways that it accesses data on those partitions. And we learned the differences between a basic disk and a dynamic disk and how Windows uses those to perform different functions with making sure that the data is redundant and fault tolerant. We've also looked at different file systems. We've looked at FAT, FAT32, and NTFS, and we've seen how we're able to use those in different operating systems. For more videos, for A+ message boards, for our online wiki, and much more, visit our website at freeaplus.com.